we can prioritize to support.
Yeah, oops, I forgot to record, so I'll start recording from now. So this is 2.0 ideas. Okay, how do I go to next slide? Okay, there you go. So learning so far from DCS 1.0 is that so it seems that many people would like to have sort of like a batch update mixing multiple kind of operations. So this was not really supported in the 1.0 API. So this is something we need to fix for the second iteration kind of thing. The second issue I see is that so ONOS Yang 2 is still evolving, and from time to time API breaking changes do happen. So probably we don't want the DCS itself to be tightly coupled with its Java object, and also similar for the binary representation, so that we don't have too much problem sort of upgrading the Yang tools along the way. And this transactional management, batch management, the configuration changes may have uses in some area outside this Yang-based configuration. So let's try to come up with a next generation DCS, which might be able to handle that situation. Was sort of the motivation.
Yeah, Yuta, can I insert a question? So can we clarify a little bit in the previous slides? Our DCS high with young tools. I think in our DCS, version 1, we actually, our design intention at least was try to decouple, right, from young tools and model specific knowledge. So our DCS 1.0, as far as my understanding, is already model independent and
yeah. So, no, I'm not talking about model independent. Yeah. Model independent is given. I'm talking about independent from the Yang tools binary itself. That will be touched on the following slide. So that probably.
Yeah, okay. I mean, I agree 100% with our design principle, right? Not to decouple with Yang tools, but I just thought that our current implementation already addressed that problem. Okay.
So this is like from the following point. So we would focus on the batch API as the first class citizen of how to interact with DCS. And another thing is that, so I'm not completely sure about it, but I mean, there is some folks saying that this configuration dataset is going to be huge, so we want to have an option to have it in some kind of external store. So let's try to keep that in corner of our mind, trying to define the store API so that we can leverage external database-ish kind of thing outside world, so that we won't be tightly tied into the atomic specific data structures. And the last point is, so try to design this not only for Yang-based configuration, but configuration in general. So what I am currently thinking is, let's try to design DCS as pretty much like a JSON storage where you can batch and read and write through its API. And the reasoning of choosing JSON was the point Henry brought up, so that so the storage format itself is not going to be tightly coupled with the Java representation of data node and so on, but use JSON as a generic form. The RFC6901, I believe this is the one that RESTconf uses to carry the Yang-based configuration. So at least for the RESTconf side, there shouldn't be, it probably should fall pretty naturally to them. And for the how do we write the batch write request, I'll have an example slide in later slides, so we can come back to that. But this is effectively list of operation in an array. So this RFC JSON patch object is, in a sense, representing the transaction object. Read this, write this, and that across the tree, and express the whole JSON as the batch write or byte write request. And the last piece is about how do we actually store this data within the cluster. And I'm thinking maybe this will be a good place where the data structure over this shared distributed log kind of things. So I have sort of a very simplified animation in the next slide, but this is in a sense sort of like, I don't know, chain of changes. So what is data structure over distributed log this is what I'm trying to illustrate. So from distributed component point of view, there's two things. There's a log buffer, which is a key value, simply a key value store, where the key is the log entry identifier and the value is the actual value. So in this example, at log entry 0.42, there's going to be a snapshot saying, okay, this is the current state. Oh, these numbers should be up 43 at this moment, but when you want to write, from the sequencer, you acquire next log entry number, and you actually write the diff against the previous state, and do the similar along the way. So if essentially, in the previous slide, I mentioned that we'll try to use the RFC's JSON patch as a storage format. So this value itself will be pretty much what that is. So in the data store, we are not going to store the actual tree structure itself, but instead keep recording the delta against the previous step from the previous step to realize how we update things. So benefit of this design is that there's only two kind of distributed primitive that we require, where on sequencer is pretty much just an atomic integer, and this one is very simple key value store map. It would be best if you have some kind of change notification, but that is not really mandatory. So we already have these two primitives in ONOS built-in in-memory store, so we can immediately start working on it. And if we, for some reason, want to move some of the data out to external database, we can do that if we really want to do that. And I pretty much talked through that in the process. But so what's going to be stored in the key value store is effectively transaction log. So that itself already represents what the batch change was. And if the key value store, the log portion, has change notification of any writes, naturally what the value contained is actually the change set that has happened. So currently we are having problem with storm of a change event happening through the doc tree kind of thing. But if we structure the data this way, we naturally have a collection of change set that actually happened on this batch write. So we don't need to come up with a new mechanics to consolidate event, but the event itself is already in a form that we would like to have. The next point was sort of like what entity wanted to have kind of thing. So it doesn't have to be a history of everything, but they wanted to have a history of things so that they can sort of go back in time. What was the configuration at point X, so that we can go back and revert it back to that state kind of thing. Since we are keeping track of the history, we can go back to the checkpoint and replay up to the point you want to see. So we have sort of features similar to the time machine feature of the history kind of thing. Now, the diagram I showed only explain in a single log entry, but in theory, you could split that into multiple log entry, like log per device and so on, so that there will be more of a parallelism and do interlog transaction management kind of things. But I think we can deal with that later on. And so maybe I should have brought this up a little bit earlier. So what does the transaction look like? So this is the one sample of the JSON patch looks like. So it's just a collection of operation where it's about the value I'm trying to write or test or deal with kind of things. So, I mean, at the end, this is exactly the kind of information we wanted to see as a change set of thing, and also this naturally gives you the ability to write to multiple part of the tree. So this will give you the batch write and also event consolidation kind of behavior that we wanted to have in DCS. And regarding the tree structure, I'm currently thinking about something like this. So first two component is sort of like the system defined portion of the tree. So device part is going to look pretty much similar to what we have today in DCS, but we do have a device tree about individual device, but I added one more layer in between so that we can have the intended store what's operational state that was on the device, and if you need to store metadata like timestamp and so on for RESTconf, we can do that. So since this thing itself is like a JSON kind of thing, the transactional update could write the actual changes to the configuration and the timestamp as a metadata in a single transaction. Then naturally we will be able to store the timestamp along with when the thing changed. So when RESTconf want to support timestamp, that information will be there. And so this CFG portion is sort of like not really something we need to tackle at the moment, but since we are just storing JSON, we could use this as a storage back end of CFG so that we can sort of start doing batch write of things. And if any other mechanics inside ONOS want to have such kind of store the configure JSON, then we can potentially use that as well. I mean, if the device speaks simply just speak REST SBI but not Yang, but if you want to transactionally update those two devices, this could potentially be used as the same mechanics. For the Yang device, we will go through the Yang related tree. For other REST soundbound device, we can potentially store the JSON which is going to be intended to send it down and do the magic kind of things. So I intend to follow something like RFC6901 JSON format where it's pretty much like the PJ's portable JSON, UTF-8 everywhere, blah, blah, blah kind of thing. Only thing that's sort of new is that instead of for the object key part, you basically follows a schema colon, then the actual value kind of thing. So I'm pretty sure this should be flexible enough that we can use it for pretty general purpose outside of Yang. So that's what I am currently thinking. And the reasoning about JSON, the very first beginning was that we want the search format to be isolated from the certain Java binary representation. And if we want some generic form of storage format, I mean, there could be XML, there's could JSON, and there could be like protobuf and so on. But if you compare between JSON and XML, I mean, definitely JSON is going to be much more concise compared to XML. So, and we probably don't need any of the stuff that XML delivers, like the XSLT and so on. So we probably using JSON made more sense. And regarding protobuf required some form of schema definition in order to get the value back and so on. So keeping track of that probably would be a little over thing. So why not just go with JSON? And if you have problem, think about it later on kind of things. And I've been Googling just a little bit, but those JSON patch and so on, there seems to be some existing Java library around that space. So if you use JSON as the internal format, we probably be able to leverage that, but that I need to do a little bit more investigation whether that is actually true or not. And so this part is really not cooked, so I don't think we need to go into it, but the only thing is that so we just need a ready API and a batch write API where we will be sending Java equivalent of the JSON patch and get the result back kind of things. And the store is it's going to be pretty simple. Only interaction to the sequencers and read write of long entries. So we can put one layer of abstraction in the middle, and which actually is backed by the atomics implementation. And if someone want to replace the susband, we can switch it to something else. That's probably it. And if you go down this path, there's still a bunch of open questions that we haven't really figured out. Is that so? But one of the things is that what is a good way to represent immutable JSON representation? So dealing with JSON in Java, the Jackson is definitely the sort of the de facto form, but the thing is they do not have a immutable representation of things. So if you really want to protect the internal data structure from the outside world, whenever we DCS return a tree, we always need to make a deep copy. Depending on what it is, this could be expensive, but I'm not completely sure. The other thing is that, so if the internal format becomes a JSON, when we ever speak to say like netconf and so on, we will need to go from JSON to data node, then back to XML kind of thing. So I was wondering what is the performance penalty of the ONOS YANG tool? If it's too bad, we probably need to optimize it. If it's livable enough, then we can just live on top of that. That's the kind of thing. And other things are a few things that we just need to investigate. JSON patch stuff, I don't think this is really a problem, so we can ignore that. And the next fourth point is something that might need a little bit of attention. So by completely removing the YANG awareness from the DCS, the kind of thing that, so YANG schema can define sort of the default value of things. So lack of configuration node implies that it means it has certain value kind of things. So if we simply replace that with JSON store, lack of the leaf value entry means it will return null kind of thing. So we need a shell around DCS to behave like a YANG configuration store. So that part of the design probably needs some more thoughts in there. And that potentially could be some kind of plugin mechanism to deal with the YANG schema out of schema-ish kind of things on top of the actual configuration store. And other thing, this is also pretty much rough sketch. So if you're going to be building a JSON database, why not use MongoDB and so on? And in my mind, for the configuration database purposes, what we need is pretty much very simple. Only thing what we really need is that we just want to have a shared view within the same cluster, and we just need a mechanism that can sort of arbitrate the concurrent writes within the cluster kind of thing. And also from the entity government, it seems that some people want history, so those are the kind of things they want to deliver. But MongoDB and so on, in my mind, the primary thing is they have sort of like a secondary index so that they can search quickly and so on. But I believe as a configuration database use cases, that kind of use case is not going to be often, so we don't probably need that. So building minimalistic thing as a shared log seems to make sense, but I'm not completely sure. So that's it. Any questions? So the thing is, so this effectively is like a pretty much almost a rewrite of DCS. So I really don't think I myself will be enough resource to complete this thing. I will pitch the same thing to the ODT and software engineering folks to see if they are interested in working in this area kind of thing. But if there is a chance that there's more people intended who shows the intention to work on this, I think it makes sense to start designing the detail of this kind of thing. But if not, I guess this will be in in a dormant state for a little bit more while. That is sort of the current thinking right now.
So Yuta, in terms of memory footprint, what would be your estimate comparing with the current?
So history-wise, it's only going to be storing the delta, so that part should be pretty much concise enough. For the checkpoint kind of things, I mean, if the memory footprint really becomes a problem, I mean, we can, I don't know, zip it or something like that if we really have to. And even if we were to use the Java object representation, vast majority of the data is a string, so storing as a JSON and storing as the Java object, the benefit probably will be almost negligible. Probably the only case is that if the data is dominated by numeric form, the string representation of numeric form, a number is going to be more bloated. But other than that, I would say it shouldn't be that bad compared to using the cryo-serialized representation of the configuration object. That is my guess. There's no data point, anything. This is my just hunch.
Yeah.
Right. Yeah, I'm not sure about. One is the memory footprint, because you're storing everything as a JSON, right? Second is the processing efficiency. If like for a typical yarn store, we're going to have tons of objects with the same basically under the same yarn schema, right? So like if I have a device, I have tons of interfaces, and each of them has this exact same or slightly different configuration or attributes. Under that. So if I need to process all of that, say if I do a query like get all of that, right? I was just thinking what would be the efficiency comparing with the current design.
Yeah, so that part really depends on the current Yang runtime's performance, how good or bad that is, recovering JSON back to the Java representation kind of things.
Right.
So, Yuta, are you referring to the process of converting JSON, right, back into a data node?
Correct. Yes, the serializer part.
Okay. So yeah. So I have a similar question as Iowa about say searching, retrieving a subnode, right, a subtree, right, from a tree. So right, current design is that we pass in the resource ID, right, as a searching key, right, and then return the subtree accordingly. With this new design, how are we gonna do that? Are we gonna still keep resource ID, or are we're gonna change that as well?
I would assume the equivalent of resource ID is going to be the path used in this format. So it pretty much I cannot select text, but effectively, so if it's an absolute path, it's going to look something like this, and you'll be like interface blah 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 kind of thing.
All right, and okay, so that basically, logically speaking, it's just a presentation difference, right? The idea is still a path, like a structure. Right. So okay, so then my question is that giving such a path, right, passing to DCS, how would DCS retrieve the data accordingly? Right now, I mean, are we still having a tree structure in the JSON format, but it's still internally as a tree structure?
Correct. So this device yanks, I would assume, will be Well, it depends on what you call a tree structure, but is a JSON. So, and I would assume this will be at least the root element is going to be a JSON object, and the leaf could potentially be another object. In that sense, that's a tree, right?
So how many? We have a big giant JSON object representing the
Right,
one tree structure, or okay, and then
this root of device yang is exactly what the REST conf and so on gonna be sending, retrieving.
Oh, I see. Then basically, if I want to retrieve a subset of the root device tree, I mean the DCS would traverse the tree down to the node I'm interested in and return it, right?
Correct.
Oh, I see. Okay. Yeah, which is performance-wise, I would see a little bit like a penalty on that.
Assume there will be some performance penalty due to the and back. Yes.
Right, comparing with the current implementation, right? Our current implementation is basically index. Basically, it's a fast search because we can think of it as indexed. All the keys are generated for each node, right? So we can do basically order one retrieval. Retrieval is order one for the current implementation. But for this implementation, depending on the depth of the tree, right, we need to traverse into the targeting node from the root and then retrieve it. Okay, I see. I got it. Okay, thanks.
Yeah, right. That's what generally I was a little bit concerned because it's depending on the complexity of the YAM model. I mean, as far as we have practiced in the field, a lot of the YAM models, like from IETF, for example, our ACTM model, right, has a very deep depth so we probably have to go through a lot of the steps in order to retrieve the data.
From in effect, what you're proposing with JSON as the storage format here is it's really like a document is what you're storing.
Exactly. So in a sense, so it will have some certain similarity with MongoDB and so on, but we don't really need secondary indexes and whatnot. Is the kind of thought, and we naturally would like to have history of things. So yeah, that's sort of the question I sort of do have. If the use case is likely to have more search and so on, why reinvent MongoDB-ish kind of JSON data store? That it will be the question that will be asked. So I don't really have a very strong argument, but the thing is that we don't need those additional features that many of the document database has. Only thing we actually need is a storage mechanism that can be shared across store. And one thing we wanted to have is history, sort of like a time machine kind of thing. In the MongoDB and so on, I assume that in the implementation backlog, I would assume they have some kind of transaction journal kind of things, but I'm not completely sure if they expose that mechanic so that we can go back in time kind of thing. So if you have direct access to those back end, which this proposed design is.
Apache Cassandra is another one of those kind of NoSQL databases that has distribution built in. That's something you've looked at?
Yeah. So Cassandra, we have very bad experience using that things. We have experience using Cassandra. operating the Cassandra cluster and the performance tuning is super painful.
Okay.
But yeah, the thing. So even if the configuration tree in SDN controller is huge, the kind of data set that Cassandra is aimed for is much bigger. It's designed for big data analytics, so that probably Cassandra is an overkill for professional database.
Okay. And just about the subject of schema then, I mean, RESTconf really, at the moment, the only constraint on that is the schema that you get from the ONOS Yang tools. You know, that's the only thing stopping you putting in gobbledygook into your DCS. You know, if you had the JSON, I don't know. I think there's a big benefit in having a schema and having, you know, a well-defined format for the information you're trying to put in. It helps indexing. It helps, you know, with metadata and navigation and all of those things. In some of your slides here, I think you're suggesting that you could go without a schema.
Correct. So I wanted to avoid a situation that we need a schema in order to decode what's stored in the database. So if you want to sort of do the validation kind of thing, after retrieving the data, you can do it at the outer shell of the DCS kind of thing. But I don't think that DCS should be the guy who should be doing the validation kind of things.
Okay.
So the configuring the storing and distributing the configuration part and the Yang sort of schema handling part, I wanted to push that outside of the dynamic config subsystem. And so it might make sense to sort of build a decorator in front of DCS specialized for Yangs. But I mean, the core part of DCS I wanted to be schema-less, mostly. Maybe only schema-ish part is these first two layers.
Yeah, okay, that makes sense. And I think probably the same concept then would be used to sort of drive the device classification and qualification part as well. You know, the DCS needn't be aware or have to consider anything about device, really. It's just a way of sort of breaking up the config, I think.
Oh, absolutely, yeah, that's exactly right. I think the validation of the schema and adherence to the schema can be enforced at kind of at the adapter layers, like RESTconf, netconf, and or device synchronizer maybe. But it's the pieces which need to actually make sense of the data in schema. Plus, also this might provide this sort of schema agnostic representation. Also lends itself a little bit better towards evolving the schema over time.
Okay.
So in terms of notification, Yuta, is that the new design would generate a similar notification as the current version of TCS?
So I would assume that if we were to use the either EC map or consistent map, update is going to be at this level. So new entry number X was added and the value was something, and that something is going to look something like this. So we were saying that the consolidated event should have, it should say that write happened and here are the list of things that changed. So this naturally have that list of things that has changed. So that is the kind of an event I would expect to see in this next iteration of DCS. So the consolidated event is the event you will get, is what we are trying
okay. Right, with path with value, right?
Yeah.
So it has okay.
Value was added, removed, replaced,
Oh, I see. Okay. Okay.
So that's that, and Windows. So I was wondering if will anyone be interested in helping out implementing this design kind of thing. I'll do similar pitch to the ODTN folks and see if there are people who be willing to invest their time in the infrastructure development kind of things, but open for volunteers, if I would say.
Yeah, I think we can certainly call for volunteers, and also like, I guess, try to like take into account the some of the concerns we have raised today, right, and try to see if we can a good way of dealing with it, especially memory footprint and efficiency. Yeah, but from ODTN point of view, yes, we certainly ask. I'm not sure if they this would be their top priority, because if they do not have a new requirement or it does not have an issue with the current DCS, I think they'll probably be focusing more on bringing up their models and implementing the business logic around the ODTN, rather than making a complete new design of the DCS.
Correct. So current focus is pretty much like learning what's in there in ONOS regard to young related stuff, and phase 2 later they'll need to start dealing with actual topology, path computation and restoration kind of thing. Then you need to start looking at operational state, which the current DCS does not have yet. So it would be best we have something by the ODTN phase 2, so we can pitch that this is sort of under groundwork that needs to happen in background. So will some people are willing to help kind of thing, but I don't know how it will roll.
I was just wondering, what are your thoughts on operational state? Do you see it being like cached in DCS, or is it something that should just be totally bypass DCS and go straight up to RESTconf?
I would assume that this, well, I'm not sure that observed is the right word, but this observed will be the equivalent of the result what you get from get netconf get request. So
okay,
this portion probably will contain the operational state, but not completely sure though whether this should be something from the device, but it should be restricted to get config or not. That's TBD.
Okay. I mean, I think it's it requires probably something to put RESTconf on its own footing above DCS. You know, I mean, I think you know, RESTconf is one thing, DCS is completely another. It's not just RESTconf is not just a shim on top of DCS. I think is where this is going.
Right. So yeah, probably there will, in order to leverage this, yeah, there's some glue code will be required between the RESTconf speaker part and adapting to this side of things.
Yeah, I mean, even things like RPCs, for instance, notification streams and that kind of thing, you know, need to be part of RESTconf, but they're not necessarily DCS related. And I mean, I think the same goes for observed. You know, observed is not something you're going to have to keep a history of or log changes or you know, index in any way. You know, are you going to cache it? I'm not sure, but you know, there's a lot of a lot of differences between the requirements of RESTconf and where DCS becomes involved. I have to drop off now to go to another call. So thank you very much. It was a very good presentation, and I would be interested in getting involved in something like this as well.
Okay, that'd be great.
Yeah. I'm going to
Thanks, guys.
Okay. Thanks a lot, Yuta, for preparing this. This is great.
Thanks. Okay, so I guess if there's no other question topic, I guess we can close today's session. Yeah.
Thank you, Yuta, for your presentation.
Just quickly, do you expect further feedback, or do you think you have enough to start sketching out the interfaces, or do you want to have a further discussion on this? How do you want to do this, Yuta?
So I probably would do a little bit more investigation around the open questions of what's out there in the world that I can leverage and so on, then start doing the API sketch kind of thing. I mean, do I need to come up with JSON patch equivalent, or if there already exists a library, we can just borrow that kind of things probably need to happen before, but I think I have good enough idea to start doing the API skeleton sketch of things.
Okay. Because I think clearly, in terms of the implementation, we certainly should look at what's available that we can use for construction of this store, right? Similarly, in terms of the API, we need to look at what approaches there are, or be familiar with RFC and all of that stuff to be inspired as to how to go about constructing the API. But I think no matter what, I think we ought to have our own API towards this. We've, I'm kind of reluctant to directly wire applications towards something that's out there, unless there was already something made specifically for this purpose, which I doubt. You know what I mean? So I guess I'm seeing our creation of our API as almost an inevitable thing. But clearly, what will be the pieces that will float across our API might be inspired or used from elsewhere. I guess kind of how I'm looking at it.
Yeah, I agree.
Okay, well, great. Thank you for putting this together, Yuta, and for running with it. Let me know how the conversation goes with the ODTN team.
Yeah, I'll do that.
Yeah.
All right.
Thank you, Yuta. Also, kind of send us feedback from ODTN as well. If you have any new material from ODTN, it would be great to share.
Yeah. Pretty much currently still setting up the logistic mailing list, blah, blah, blah kind of thing, and nothing technical is happening yet. So hopefully that kind of things will start happening next week when the use case team has the first meeting and so on. So let's see.
So, by the way, Yuta, are you guys will all be there at ONS?
ONS, so
yeah,
end
of March.
But the many of the ODTN attendees coming to OFC, so we are thinking there might be sort of a meeting at OFC.
Right, OFC definitely. OFC, I think it's second week of March, right? And ONS is the last week of March in LA.
Yeah, dates were pretty close by, yeah.
Right, because I was talking with William yesterday, and kind of suggesting that it might be good if we have a dynamic config, like a Brigade meetup, sometime around ONS work session.
Oh, good.
So,
that might be some good idea.
Yuta, I can chime in on that because I heard from William, and basically we have a couple of rooms at ONS for the days before the event itself, meaning the Monday, and probably some specific rooms also on Tuesday. So we could leverage that if that's of interest of everybody in the Brigade.
Right. So I think it would be good if like most of us will be there. We'll be able to make get together and sync up meeting on this. Yeah. So we kind of talked about like Monday or possibly Tuesday, but I think Tuesday might be a little bit too intensive. It's the majority of the topics starting like Tuesday morning.
And all that's
so,
probably going to be there. So yeah. If it's going to be if it's going to be day before the ONS, I need to know before I book my flight and so on. So let me know.
Oh, okay. So you already booked, or you
No, I haven't booked yet. I haven't even registered and so on. So I'll probably need to do that soon. So if it's likely it's going to happen on Monday, let me know and I'll change our arrangement.
I'll confirm with William on the setup. Probably Andrea, you could also help with that. But I would shoot for primarily like Monday, and if not like whole day, maybe an afternoon or something like that. Yeah, that might be the way to go.
I agree. Yeah. Let's try to shoot for that.
Okay. Yeah, I'll confirm with everybody once it is set.
Okay. Yeah, let me know if I can help.
Yeah, certainly. Thank you. Yeah.
Okay, thank you.
Also, Yuta, if you think you need to schedule a meeting or kind of off schedule, please don't, or need any help, please don't hesitate to.
Okay. Yeah, probably I'll try to come up with the skeleton JSON, Java code or so on, then just try to sync up at that point. Yeah.
That's great. All right, we'll see you next week.
Okay.
Okay. Thank you guys. See you next week. Yeah. Talk to you.
Bye, everybody.
How do I stop recording? Anyway.
Yuta, you just close.
Close, and you should automatically stop recording. Okay. Then I'll just close it. Okay. Thank you. Bye-bye.